Well, people, we are now on our 4th lecture. And if you look at your program, you probably were expecting Colin Atwood to be here. And if you know who Colin Atwood is, you'll know that this young man is not Colin Atwood. We have Denham Parker here because Colin unfortunately had to go on a cruise. I mean, he's a marine biologist and sometimes there's a calling and he has to make it. So he had to go and he's asked Denham Parker to come and stand in for him. Denham is currently a postdoc in our department in the biological sciences, and he has an interesting career, young career. He has a PhD from Rhodes University, where he was involved in the Tecopa Marine Reserve, looking at fish stocks in the area, and that research was done together with Rhodes University and Sion. Now he is in our department looking at commercial fisheries. For all you fishermen out there, he's looking at the effect of fishing, commercial fishing and fisheries on the stocks at the moment, on fish stocks, sorry. So I hand you over to Denham Parker and he'll entertain us about the extinctions that we're experiencing in the aquatic realm. Thank you.
Thank you. Can everybody hear me in the back? Perfect. Good morning, everyone. Before I start, I'd like to let you know that this is my first official lecture that I'll ever be giving. So thank you all for coming. Thank you. Towards the end of last year, when Professor Colin Atwood got hold of me and he said, I think it's time you should start doing some lectures, I really thought he would ease me into it quite gently by giving me maybe a small class of naive 18-year-olds, but clearly he had different things in mind. So today I'm going to be talking to you about aquatic extinctions, and this focuses on both the marine extinctions and the freshwater extinctions. And the period we're going to be looking at is the Anthropocene. So as you've probably heard from the last lectures, this is the most recent period where we see that humans have had a profound impact on the biodiversity of the world. This is quite a broad topic. What I've tried to do is I've tried to pick the interesting species that have gone extinct, or the species that have gone extinct for interesting reasons. And the one thing I would like as a take-home message for you guys to take home from this is the different processes that lead to a marine extinction and a freshwater extinction. What we see in the freshwater ecosystems is that they're characterized by a high level or a high rate of extinction, and it's normally one or more processes that are acting on a species for it to go extinct. In contrast, what we're seeing in the marine environment is that extinction rates are very, very low or quite low, and it's normally only overexploitation by humans that lead to these extinctions. So these environments are similar in a lot of ways, but they're also very different in a lot of ways, and it leads to different management situations that we have to apply to these organisms. But before we start, does anyone know what that is? So that's the Yangtze River dolphin, and that was declared extinct in 2006. And that was a result of industrialization in China and the use of the Yangtze River for industrial transport and obviously pollution, which led to its eventual demise, which is pretty sad because dolphins are really intelligent species. So before we get on to the extinctions and that, we want to maybe recap on where the Earth's water is, or where the Earth is distributed around the water. And the obvious one is we see that 96.5% of the water on Earth is in the oceans. So the oceans are vast bodies of water, normally single bodies of water that something like a whale can move from one end to another. In contrast, we see that freshwater only makes up 2.5% of the water on Earth. But remember, when we're talking about extinctions, we're trying to talk about environments that microorganisms can live in. So that's not completely true. We've got to break that down even further. We see of that 2.5%, 68% is in glaciers and ice caps, which nothing really lives in, and 30% is in groundwater, which is also not suitable habitat. So of the 2.5%, 1.2% is on surface freshwater. So it's a tiny amount. We then break that down even further, and we see only about 25% is in lake, rivers, swamps, etc., where we see the freshwater organisms being extinct. So what we get is freshwater ecosystems only cover about 0.8% of the Earth's surface, but they account for about 10% of all the animals on Earth. So that's a lot of biodiversity in a very, very small area. And this feeds back into what Peter said about island biogeography, in that if a species has a limited area in which it lives, a small home range, it's more likely that it's going to become extinct. And that's what we're seeing in freshwater ecosystems. We see that dams are these isolated islands as such of freshwater in an environment. And if there is a disturbance within that freshwater, the animals simply can't move. They're stuck there. And most of them, or some of them, may die because of that disturbance. And that characterizes why we see quite a big extinction rate in freshwater species. So some quick statistics on it. Freshwater extinction rates are the highest of all organisms, particularly our freshwater fishes and our amphibians. They're in a lot of danger. And freshwater fishes may now be the most threatened group of vertebrates, at 36% of all fishes considered to be threatened. So why are they threatened? What are the processes that they're going through that are causing these extinctions? Well, the most important is habitat modification, fragmentation, and destruction. This has been touched on in the past, but I'll go through it. The amount of water that's now currently impounded in dams has quadrupled since the 1970s, and that's purely a result of this need for vast agriculture. So when you dam a river, you change the environment dramatically. Organisms that have evolved to live in a fast-flowing, shallow environment now have to deal with a static environment. Some of them can't deal with that. On top of that, you're now stopping things like salmon and eels that migrate up a river to breed and to feed. They reach this physical barrier and can't do that anymore. So this is obviously a problem for them. But the biggest problem is this competition for freshwater. It's a finite resource, and there's a lot of people trying to get it. And the more we take away for agriculture, the less there is to provide habitat for these species. And that leads to a lot of biodiversity loss. And then the second is invasive species. This is a big thing in freshwater environments. All these fish here have been introduced into South Africa as alien invasive, either for recreational angling purposes or for aquaculture. We have the largemouth bass, the common carp, the Nile tilapia, and the rainbow trout. The largemouth bass and the rainbow trout are highly predatory species, and they've played havoc with our small minnows, our native small minnows. Particularly the largemouth bass has really decimated the redfin minnow population in the Western Cape and the Eastern Cape. And the rainbow trout has decimated the Maluti minnow up in the Lesotho Highlands. The Nile tilapia is slightly different. That has been spread all around Africa, and that's for aquaculture. It grows quickly, it reproduces a lot of offspring, and it's a good source of protein for food security. The problem with that is it completely outcompetes all the native tilapia. On top of outcompeting them in terms of food and reproduction, it hybridizes with other native tilapia. But the offspring of a native tilapia and a Nile tilapia are infertile. So what we see is the native tilapia puts all this effort into reproduction and hybridization with this tilapia, and it goes nowhere after one generation. That essentially it ends. So we see a slow decrease in the population numbers because of the hybridization. The next is overfishing. Obviously, this is a big problem in freshwater environments, particularly within Asia and Africa, where food security is a problem. We have a growing human population. They need a source of protein. They often look to freshwater fishes for that source of protein. The giant Mekong catfish in Asia the populations have been overexploited. Historically, in Europe, the sturgeon was completely overexploited. There are management things in place, and it seems to be recovering a bit better. And the interesting one is the European eel. So this has been exploited for a long time. The adults have been exploited. But since the 1970s, there's been this growing need or demand for the alvas, the small eels, in the east. So in 1970s, they started collecting the alvas as well. And what that does is now you're collecting baby eels that haven't had a chance to reproduce, not even once. Okay, so that decimates the population numbers. And what we see now is that the European eel is decreased in numbers by 98%. So it's at 2% of what it should be. So overfishing is a big problem. Environmental pollution is another problem. This comes in two forms, essentially. There's the point source pollution, which is the obvious one. There's people dumping stuff straight into rivers, storm river drains that go straight into a dam, etc. The impacts of that are pretty obvious. But then there's the more complex one, which is called diffuse pollution. And diffuse pollution happens a lot in agriculture. And what happens is, because we're farming so intensively, we're putting all this nitrates and phosphates in the form of fertilizers on our crops, as well as pesticides. When it rains or when they're watered, they seep into the ground, they get into the groundwater, and they make their way into the freshwater. Now, if you put a lot of phosphates and nitrates into a freshwater ecosystem, you get an algal bloom. There's so much nutrients in that system that algae bloom, and they reproduce at a rate that's not sustainable. That obviously changes the composition of the freshwater ecosystem, and other organisms may die as a result of that. Then, of course, there's the third, which is slightly more complex and probably not spoken about as much, and that's pharmaceutical pollution. So when you take any pharmaceutical, your body doesn't metabolize every single hormone or every single pharmaceutical that's in it. It releases some when you go to the loo, and then you flush the toilet, and that ends up in our freshwater environments. Now, to put it into perspective, every year in America, 60 million antidepressant prescriptions are written. So you can imagine how many contraceptive prescriptions are written. And all of this is going in minute amounts, but it's getting into our freshwater systems. And it ends up with something called endocrine blockers. And these blockers essentially interfere with the metabolism of the organisms within the freshwater. So we see here the major concerns to date have been increased bacterial resistance to antibiotics and interference with growth and reproduction of aquatic organisms. The level of risk to humans and the environment is still being determined. We don't really know what the large-scale risk for this is. It's a difficult thing to try and predict, but it's quite scary. Obviously, forestry, it's a pretty obvious one. When you deforest an area, there's no longer vegetation within that area to hold the soil together. As soon as you get a bit of rain, the topsoil seems to disappear off, and you get siltation within the rivers, which may make the rivers more turbid, may change their chemical composition, and some organisms which aren't used to that may die off. And then, of course, you have to talk about climate change. If we look at what organisms are most at risk, within the freshwater for climate change, we see that amphibians are at high risk. And how a climate change may work on a freshwater ecosystem is obviously an increase in temperature within a water body. But more than that is this variability in our climate. More rainfall sometimes, more flooding, more droughts. This extremities, more of the extremities. I mean, we're currently going through an El Nino. We were talking about it now. And you notice these extreme weather patterns are becoming more frequent. And that may interfere with the hydrological process of a freshwater system and may then have knock-on effects for the organisms within that system. So those are all reasons why the freshwater aquatic systems are really susceptible to extinctions and depletions, or depletions and then extinctions. So I've chosen one example here of a freshwater fish that's gone extinct, and that's the Tecopa Pupfish. This was a very unique fish. It evolved to tolerate very high water temperatures. It actually lived in the hot springs of the Mojave Desert in America. So it was very tolerable of high water temperatures and chemicals. And it was a small fish. It ate insect larvae, etc. But the problem with its habitat was in the 1950s and the 1960s, these hot springs became extreme tourist attractions. People flocked to them to go sit in the warm baths. That meant that there was a change in habitat. They started widening these pools. They started damming the pools, as you can see. a consequence of that is that this pupfish was first forced further and further down the riverbed or the river stream, further and further away from the source of heat into colder water. They couldn't withstand the cold water and they went extinct. And in the 1970s, the species was declared extinct. So that's just a nice example how a pure human leisure activity, something like sitting in a warm bath, can cause an extinction within a species in 20 years. So we saw that amphibians are very, very susceptible to extinctions, and within that, frogs are probably the most susceptible. So why are frogs going extinct? Well, climate change is an obvious one. Estimated 170 species extinct in the last 10 years, a further 1,900 threatened according to IUCN, and a fifth of the frogs in South Africa are under threat of extinction. But there is another reason as well, another major factor that's playing in this, and that is the chytrid fungus. So chytrid is a fungal-borne disease that is toxic in 80% of amphibians around the world. The fungus essentially makes the pores on the skin of the amphibian non-functional, and that's big for an amphibian. They use them to breathe to some extent, the pores on their skin, but they also use them to hydrate. They take in water from these pores. So if you make these pores non-functional, the frog eventually dies from dehydration. So where did this fungus come from? How did it spread around the world, and how is it devastating our frog populations? Well, it's thought to originate from the African clawed frog. And the problem with that was that until the 1960s, the only reliable pregnancy test was to inject a woman's urine in a female African clawed frog. And if the woman was pregnant, the frog would ovulate within 12 hours. So this frog, the African clawed frog, which was immune to the fungal-borne disease, was spread around the world for medical reasons to develop a pregnancy test. And with it, it took this fungal disease and spread it on to other species, which has resulted in quite a lot of frogs dying off. So that's the freshwater side of things. And like I said, a lot of the point of this talk is to contrast the freshwater and the marine, to see that there's multiple effects that lead to a normal freshwater extinction. I'm going to talk about the marine extinctions now. And what we see is the list of marine extinctions, or the list of species that have recently gone extinct, tallies to around 20. Okay, there's some arguments about this. There may be some Lazarus species. There may be some that they're still looking for, but it's not a huge number, surprisingly. And if we look at why these species have gone extinct, it's generally human exploitation, and it's generally in the 1600s or in the history of human exploration. And what we see is that mainly air-breathing, land-breeding mammals and birds have gone extinct. Okay, so it's not really your fish, it's rather your larger animals that have or reproduce only a few offspring. So if we start with birds, there's 5 that we know of that are common extinctions that have happened throughout the world. The first, we can talk about the spectacled cormorant. This was found on the Bering Island. Okay, so in the 1600s, when explorers were exploring the North Atlantic, they took advantage of this bird. They hunted it for its down and for its meat, and it subsequently went extinct. We then have the Labrador duck. That was found in New England and New Jersey. It again was hunted for its meat, and its eggs were collected and eventually went extinct. The Canary Island oystercatcher is slightly different, obviously from the Canary Islands. And the way this is thought to have gone extinct is that there was overharvesting of intertidal mussels in the Canary Island. That was probably their main source of nutrients. So when you overharvest the mussels, the bird dies too. The Auckland merganser, again hunted on the Auckland Island in New Zealand, but also possibly the introduction of a mammal which may have predated on it led to its extinction. And then finally, there's the great auk. This is probably the most popular seabird extinction that we know about, and it's simply because the numbers in which it was killed. It was killed in thousands and thousands. So It lived, again, in the North Atlantic on the rocky shores. It's a small penguin-like bird, flightless, small wings, probably only stood about 75 centimeters off the ground. It lived on rocky islands and had one egg in which the male and the female both incubated. They took turns. The problem with this is it was completely naive to any predators, like the dodo and like many other things. And there's stories about sailors who went exploring this North Atlantic and would step out onto these islands. And the one story is that these great auks were so abundant that, written in the story, is the sailor didn't know where to stand because he feared he would be stepping on auks all the time. So he had to brush them out the way to put his foot down. The other story is that they were killed in such numbers that the sailors would literally herd them up the gangplank and onto their ship where they slaughtered them in the hundreds. So there was just mass slaughtering of these birds for food, for down, and for their fat, which they used for oil. In 1770s, they obviously realized that this is not on. We carry on killing these birds in this rate, they're going to go extinct. And killing the auk became illegal, and punishment, and collecting its egg also became illegal. And punishment for that was public beatings, which is maybe a punishment we must reconsider. Anyway, but there was an exception for that, and that is if you were a fisherman, you were allowed to kill the great auk as long as you used the meat for fishing bait. So by late 1700s, the great auk had also gone extinct. Then if we look at the mammals, there's three mammals that have gone extinct, marine mammals that have gone extinct. We have the Caribbean monk seal, the sea mink, and Steller's sea cow. So the Caribbean monk seal also was heavily hunted by the explorers like Christopher Columbus and etc. around the Caribbean area. But they lasted quite a long time. They were hunted for their fur, or for their skins, and for their meat and for their fat. But like I said, they lasted through that. They managed to get through that. They lasted, and the last sighting of a Caribbean monk seal was in 1952. In 2008, unfortunately, it was declared extinct, and that was after a research group searched for 5 years to try and find one. The sea mink, unfortunately, fell to the European mink fur trade. So it was a small otter-like animal that lived on the coastline of North America and Canada. It was heavily hunted for its fur or for its pelt, and they would hunt them in traps, or trap them, or hunt them using dogs, and obviously they would be skinned, and their pelts would be sent to Europe, and they went extinct in the 1800s. And then another interesting one is Steller's sea cow. So Steller was the main naturalist on the explorer Bering's voyages up in the North Atlantic. So that's where you get to Bering Island and the Bering Strait from. And on one of these trips where he was the main naturalist, they had to spend a winter over in Alaska for some reason. And that's where they found Steller's sea cow. So they were wintering over in Alaska, and they needed sustenance. And Steller first described the sea cow as a docile, cow-like, massive animal that simply grazed on kelp all day. So again, it was completely naive to any sort of predation. Throughout that winter, they killed a lot of them for food, for oil. Their meat was apparently delicious, and for their skin, which they made into jackets and stuff. Obviously, when they eventually made it back to where they came from, word got out that if you're exploring this area, and obviously you need sustenance, Steller's sea cow is quite an easy prey item, and it produces, or you can use all its body parts. So within 27 years of Steller describing the sea cow, it went extinct. And it was a huge animal. I mean, it was 10 meters long, weighed 10 tons, and it was, it's a direct relative of the dugong, and the manatee. So you can imagine what kind of animal it was. I mean, there's multiple stories like this, how these early explorers devastated the mammals and the birds on all these islands that they visited. Obviously, they needed sustenance. A lot of what they killed was completely naive to any predator, and they just wiped them out. And there there was too much information, obviously, to put into this talk, but if you're interested, I can really recommend this book. It's called The Unnatural History of the Sea by Callum Roberts. It's a very good book. If we look at invertebrates, it's slightly less exciting, but a couple have gone extinct. The Chinese periwinkle and the eelgrass limpet. The eelgrass limpet apparently succumbed to disease. The Chinese periwinkle, there's not a hell of a lot of information on. There is possibly a third one called the horned snail, which I think originates in San Diego. But yeah, only a couple of invertebrates that we know of. And also 2 algae species. We have the Turkish towel algae and Bennett seaweed. Both of these were found within the Sydney Harbour, and both of them have subsequently gone extinct. And the reasons written down why they went extinct is unknown human impacts. So it's more than likely habitat modification as well as pollution. And finally, we get to the fishes. This is where my interest is. We have 3 fish that have reported to have gone extinct, 3 marine fish that have reported to have gone extinct. We have the New Zealand grayling, Galapagos damsel, and the green wrasse of Mauritius. Now, the New Zealand grayling is a diadromous fish. What that means, it lives in both freshwater and saltwater, so it migrates from one to the other. And the reason it went extinct was because of deforestation in New Zealand, which obviously led to silting up rivers and the rivers getting turbid from wash-off of the topsoil. And that probably wasn't great because it was probably relied on eyesight to get its food. And then on top of that, or to compound that, the alien trout was introduced to these rivers in New Zealand as well. So that wiped the species out. The reason I'm skeptical why we call this a marine extinction is because although it lived in both the marine and freshwater, the disturbances that probably led it to extinction were within the freshwater part of it. So can we call it a marine extinction? It's a tough one. The Galapagos damsel is thought to be extinct. It hasn't been confirmed yet. This is a species that lives in the shallow waters of the Galapagos Islands. And the theory here is that the climate change and warming of the ocean in that area, because it's so shallow, has led to the species not being able to handle such high temperatures. But they're still looking for populations, hopeful for populations. And then there's the green wrasse of Mauritius, and this was thought to go extinct off the islands of Mauritius in the 1800s, and it was thought to be a result of the huge amounts of sugar cane that was planted there to satisfy the demands of sugar in Europe. Obviously, when they planted the sugar, again, a lot of runoff of silt, and this covered the coral reefs around the island and killed the coral reefs around the island. Wrasses are very dependent on coral reefs for both food and habitat, so the thinking was that when the coral reefs died off, the wrasses died off as well. However, recently, what they found, or what a bunch of scientists found, was that the Mauritian green wrasse never actually existed. It was this. It was the blue-spotted wrasse. So what we know about wrasses is they're phenotypically plastic. So what that means is though they may have the same genetic makeup, but their physiological appearance may differ where they live, what depth they live in, or what life stage they're in. So what probably happened is in the 1800s, someone misdescribed the spotted blue wrasse, or the blue-spotted wrasse, as a Mauritian green wrasse. And these are still common around Mauritius. So essentially there wasn't an extinction there. And that reminded me of a nice Mark Twain quote that if there's any anglers in the room, they can probably relate to. And that's, do not tell fish stories where the people know you, but particularly don't tell them where the people know the fish. Okay, so we can't actually come up with a single marine fish species that's gone extinct, okay? Not concrete proof of that. Does that mean our marine stocks are in a good, healthy state? Our fish stocks? No. Not at all. In fact, what we find is that 75% of major marine fish stocks are either depleted, overexploited, or being fished to their biological limits. So our marine fisheries are in a bad way. But does this equate to marine extinctions and marine fish extinctions? Well, obviously not. And that's hopefully something I'll be able to answer just now. But first, let's have a look at South Africa's threatened marine fishes. Okay, so we have the six main threatened fishes are the white steenbras, which is at 6% of the pristine population. So what that means is we've taken the pristine population and we've decreased it by 94%. We have the black mussel cracker, which is at 15% of pristine population. Red steenbras, which is at less than 5%. Red stumpnose, which is at around 5%. We have the 74, which is at less than 5%, despite a moratorium being on the species. So no one's allowed to legally catch the species for the last more than a decade. And then duckrat, which is also at less than 5%. So clearly, these are our most threatened marine fishes, and they're in a bad way. I mean, less than 5% is nothing. But is there a probability any one of these will go extinct? That's a difficult question. I personally don't think so. Incidentally, so these fish are all belonging to one family, and that's the Sparridae family. They're all sea breams. And the reason they really can't handle exploitation by fishing is because they're long-lived, slow-growing species. Some of these fish can live up to 40 years old. So when you take one fish out, it has the potential to take 40 years to replace that fish. Okay, so if we don't think they're going, or if I don't think they're going to extinct, let's look at the mechanism which we quantify probability of extinction. And we do that using the IUCN red listing approach. And what the IUCN is basically, it's a bunch of categories which your species will be evaluated and put into a category which should tell you the probability of that species going extinct. And then the threatened categories are the ones we're looking at. Obviously, if you're in the threatened category, there's an issue. And what we see in terms of numbers is that to fall into the threatened category, an observed, estimated, inferred, or suspected population size reduction of greater than 50% needs to happen. So you need to take your population and at least halve it, and then you may get into a threatened category. If we then look at the management protocol for the South African line fishery, we find that a population that is 40 to 50% of the pristine population, so it's been decreased by 50 to 60%, we consider optimally exploited. We're actually aiming for that. So where's the difference? There's obviously a mismatch somewhere here. And the difference is that marine lionfish are not like many other organisms. This tool here has been developed to be applied to every single animal in the world, animal, plant, organism in the world. Marine fishes are just slightly different. We're looking to aim for 40 to 50%. That's an optimal exploitation of a fishery. So we've shown that our marine fish are simply, not that we know of, going extinct, the ones that we're overexploiting. So why do we still see headlines like this? Saltwater fish extinction by 2048. And I must stress here, that doesn't mean our fish are not in a bad way. They are in a bad way. They're just not going extinct. Well, this is a CBS News article that was taken from a research paper that was published in Nature in 2006 by a scientist called Worm. And what the news article failed to say was that the scientists actually described extinctions as commercial extinction, which is very different to actual extinction. So if we have actual extinction, the species no longer exists. We have extinction in the wild, it no longer exists in the wild. If we have commercial extinction, it means there is no longer a viable fishery for that fish. Okay? It makes no more economic sense to fish for that fish. Once the population gets below a certain threshold, the amount of money you're spending to go find that fish cannot be outweighed by the amount of money you're getting by selling that fish. So the fishery stops, and basically exploitation on that fish ends. So it all comes down to economics. It's not worth fishing out the last fish in the sea. It doesn't make economic sense. And this can be described in a very simple bioeconomic model called the Gordon-Shaffir model. Gordon was an economist, Shaffir was a biologist, and together they came up with this model. And I'm not going to go into too much detail. It's a pretty simple model. But on the y-axis, you have your total revenue, how much money your fish is bringing in. On the x-axis, you have how much money you're spending going and catching that fish. So anything above this straight line is profit, below is obviously making a loss. And what we see is if you're spending a lot of money going and finding the fish, which you would if it was the last fish in the sea, you better be catching a lot of fish to make up that money. And this basically explains a simple reason why we don't fish marine fish to extinction, because it's not worth it. There is another reason, though, why marine fishes aren't susceptible to extinction. We can fish them to a low population, they're not going to go extinct. Sorry, but back on this model, there are two fundamental assumptions that I must mention with this model. The first is that there's no government subsidies. What we find is as soon as a fishery starts becoming non-lucrative, you don't want to lose jobs, government may pump money into that. The assumption is in this model that doesn't happen. The other is that the price of a fish remains constant. But what we actually see is the more rare species become, the price increases, it becomes a luxury. So those are two assumptions you must keep in mind with that model. And then there's this fecundity. This is another reason why marine fishes just don't go extinct. Fecundity describes the amount of offspring an individual can have in its life. Okay, so what we saw in the great auk, which was the bird that went extinct, they laid 1 egg a year. What we see in a lot of marine fishes is they can lay thousands of eggs multiple times a year. So the potential to have offspring is huge. You may fish this fish down population to a very low number, but it's resilient. It can make, if given the opportunity, it can rebound because it can have a lot of offspring. That said, this has been overstated a number of times, and people continue to overstate this. It's not as resilient as we make out. And the most famous was in 1883, where a fisheries scientist called T.H. Huxley stated, I believe then that the cod fishery and probably all the great sea fisheries are inexhaustible. That is to say that nothing we do seriously affects the number of fish, and any attempt to regulate these fisheries seems to be useless. Well, poor old Huxley is probably rolling in his grave right now, because a lot of fisheries have collapsed throughout the world, and particularly the fishery he was talking about, which was the Atlantic Northwest cod fishery, collapsed in 1992, and a moratorium on the species was put in that afterwards, and the species still hasn't recovered fully.
Do you think perhaps in 1883 it would have been more or less possible because there were fewer people?
Definitely.
Yeah.
But I think he was talking in terms of forever.
Oh.
And then finally, one of the reasons we don't see, or we haven't documented a lot of marine extinctions is simply because of ignorance. Only 1.9 million species have been described out of an estimated 9 million species that exist. So, how do you know something's gone extinct if you never knew it existed? That's obvious. The irony here is that the species that are most likely to go extinct are rare species. It's very difficult to find rare species in the sea. And an obvious example of this is the coelacanth. I mean, it's a great example. We thought the coelacanth was a prehistoric fish that was extinct a long time ago, all the way until 1938 we thought this. And the only evidence we had that a coelacanth ever existed was in fossils like this. Then in 1938, a woman called Miss Latimer described the first one and sent it off to J.L.B. Smith. 20 years later, or roughly, J.L.B. Smith was flown to the Comores and he described the second one. Today we know we have quite a healthy population of coelacanths on our doorstep off Sodwana Bay in the canyons, particularly Chesapeake Canyon. So what have we missed if we were able to miss an iconic species like this for so many years? We've obviously missed a lot. And then obviously, I can't talk about marine extinctions without talking about what has been proposed for the future and what's predicted for the future with regards to climate change. And there's two main processes that climate change seems to impact on the marine environment. The first is coral bleaching. So coral bleaching occurs when there's sustained high temperature, water temperatures in an area. And what this does, it basically breaks down the symbiotic relationship between a coral and the zooanthelle, which is the algae that lives within the coral that gives it its color. When that symbiotic relationship breaks down, the coral expels the zooanthelle and it loses its color, and that's where the bleaching comes from. So there's an obvious impact on this in terms of extinctions on corals. We expect to find more of this. It can recover. It's not fully dead, but they generally don't recover. So we expect a lot of extinctions in the future for these corals. But what's the knock-on effect? What's the ecosystem effect? What about the fish that rely on corals for habitat? What about the fish that rely on corals for food? What about all the other organisms? This is something that's very, very difficult to predict. It really can't be predicted, not at the magnitude when we're dealing at climate change at a global level. It's difficult. And then there's ocean acidification. This is the second process. And what this is the ocean is very good at taking up excess CO2 that's in the atmosphere. The CO2 then dissolves in the ocean, and eventually it ends up as bicarbonate. But in this process, there seems to be an uptake of any free calcium that's in the seawater. And this is a problem for organisms we call calcifiers. Now, calcifiers are organisms that have hard structures. They need calcium to make those hard structures, such as your corals, your crabs, your lobsters, all those sort of things. So if they don't have this calcium to make these structures, what's going to happen? What are the ecosystem impacts of that? Again, you're dealing with something that's at a global level, and it's extremely hard to predict. And we're predicting into the future. It's a very difficult thing to predict. Okay, so unfortunately, the nature of an extinction talk is that it is going to be quite gloomy, and there's going to be a lot of bad news. I'm sorry about that. But it's not all bad, okay? I work within the fisheries department of South Africa, and we have a hell of a lot of intelligent people working on the problems that we face today, okay? And our fisheries are probably one of the best managed in the world, which we have our problems, and it probably doesn't speak volumes for other countries in the world, but we're dealing with them as best we can. But you, as a consumer, also have something you can do. Obviously, if you refuse to support unsustainable fishing methods, that fishing method itself will eventually go extinct. So please, next time you're looking at buying food or buying fish, please buy MSC certified, or try stick to the green list fish on the SASSI websites or on the SASSI pocket books. Also, if you're an angler, get involved in research. There's a number of tagging programs out there. There's also the Fish for Life website. That's a new website which UCT and WWF have collaborated in. And what we're basically saying is every time an angler goes out, they collect data. Whether they know it or not, they're collecting data. We want to use that data. So if you visit the Fish for Life website, you can see how you can get involved. If you're an angler, please be aware of the regulations and please stick to them. These regulations, a lot of time and effort has gone into making those regulations. Thank you.
Thank you very much. Thank you, Denham. I think you all must admit that was a fabulous first lecture.
Can you just say, if we have only identified 1.9 million species, how do we know that there are 9 million?
Yeah, that would be what you call an educated guess, I suppose. And that wasn't marine species, obviously. That's species throughout the world. And it would be taken on the rate at which we're identifying species. So then that would be extrapolated forward. It ranges between 7 and 14, so that gives you an idea of the guessing involved.
Could you comment on how much damage has been done to the coral reefs? There has been some alarming reports, whether they're true or not, I don't know.
Yes, a lot of damage has been done to coral reefs, unfortunately, but to answer that question, you've got to look at specifically where we are. Africa, unfortunately, has a tendency to use a lot of unstable fishing methods, such as dynamite fishing. That has huge impacts on coral reefs. So some areas of coral reefs are well looked after, well maintained, or well protected, I should say. Some are terribly protected. And what we're seeing is the ones within the tropics are very, very susceptible to bleaching because obviously those temperatures in the water get the highest. The ones we're seeing in Sodwana, which are more towards the South Pole and are a bit cooler water, they're more resilient to stuff like bleaching because of the environment they are in. It's a very difficult question to answer, but coral reefs are in a serious state, unfortunately.
We see frightening reports about the continental-sized floating plastic bags in the ocean. Could you say something about the impact of that? The other one, can I ask two questions?
Yeah.
Are there any global regulatory processes in place? I'm thinking of the mining development in Australia right on the barrier reef.
Okay, for the first one, the plastics. Obviously, plastic is a huge problem. And what we see a lot, it was day before yesterday's lecture, plastics are bad for seabirds and stuff that will tend to pick it up and try and consume it. And that's something that gets washed up on the beach, like a plastic bottle lid. Straws are particularly bad, and they get washed up on beaches and things try to consume them. So there is a massive impact of plastic in the ocean. Again, it's a very hard thing to try to quantify. No one's going out there counting plastic bags in the ocean, unfortunately. And then in terms of the mining regulations obviously have to go through EIA processes, so environmental impact assessments. And they have to justify that if they are damaging an environment to any extent, they have to counterbalance that. So there will be mitigation processes to counterbalance that, or the EIA simply won't be passed if those mitigation efforts are not satisfied. Unfortunately, in countries where development, such as South Africa, where development is taking priority sometimes over natural preservation or conservation, these EIAs may not be as good as they should be. That's the most I can say.
How effective can fish farming be in compensating for the decline in fish numbers?
Again, it depends on what you're farming. So if you're farming highly predatory species, high-value species like your salmon and your cod, if you're farming those, not very effective at all. You're basically using 1.5 kilos of fish feed, which comes from fish oils of smaller fish, to feed to that fish, to make 1 kilo of fish. So you're feeding more fish to make less fish. So if you're looking at a species like that, that's a high-level species and it's a high-market species, you're not sustaining any sort of food security from that. If you then look at the smaller scale of stuff and you look what they do in Asia, where they have a pig farm that then runs off into a koi farm, and it's one cycled process where at the end of it, the nutrients from your pig waste and your farming is going into a little pond where you're growing fish, then it's very sustainable. So there is opportunity for it, definitely. A lot of the sad side that we see is a lot of these high market value species are being thrown in under that opportunity when they're not. They're marketing for high priced products.
I understand that nearly half the fish consumed in the world are in fact farmed fish. Is that true?
I wouldn't know about that number exactly. I wouldn't think so. Maybe in the freshwater environment, but not in the marine. Certainly not in the marine. So freshwater, obviously farming, with the more rural aquaculture, the stuff that's been developed like in Asia, that through tradition, they do provide a lot of fish. But your marine stocks are still very reliant on fisheries.
Two interrelated questions. The first is, according to marine protected areas in South Africa for sustaining fish stocks, and the second is the recent opening of Tecopa and the fishing. Do you think will have any impact on that? Sorry, what was the question?
So the question was, how important are MPAs to maintaining fish stocks in South Africa as a conservation process? And regarding that, what is the effect of the new opening of the Tecopa to shore angling? What do I believe the effect's going to happen? Well, MPAs are very effective for not only maintaining fisheries but maintaining ecosystems. Recently, there's been a move away from trying to protect a species, a single species conservation, to more an ecosystem approach, where we feel that if we maintain an ecosystem, that fish within the ecosystem as well as others will be protected. And that's MPAs fall directly under that mandate. Obviously, you're cutting off an area, and if the MPAs are well placed, where some of these very threatened species aggregate to spawn, they're extremely effective. The problem is people lose access to that area, and that's always going to be a problem. And with regards to the Tsitsikamma MPAs, the MPA opening is obviously terrible. I did my PhD there. I have a love for that MPA, and it's devastating for me. But the ecological impact may not be huge, but it's more so where are we going in terms of the government's policy. If we open the Tsitsikamma MPA now, which MPA is next? And this is the stance we're taking, is like, you're opening our oldest no-take MPA against all scientific evidence. What's next? Everyone else in the world is moving forward with proclaiming MPAs. Why are we taking a step back?
Why?
It's an election year. It's an election year.
Is there not a need maybe for much stricter catch reporting? So with the big commercial companies are going out to catch this kind of fish, but they've got a byproduct, bycatch of this and this and this. Is there not a huge amount of under-reporting?
Yes and no. Obviously, there's always a need for stricter catch reporting. I think South Africa, especially the big companies, what we see is the big companies have a vested interest in maintaining their fishery. They're not looking for the next 2 or 3 years. They're looking for the next 100 years. So they actually do really well. So your INJs, etc., they report really well. It's more so the small-scale stuff where we see under-reporting. And I'm talking in South Africa. Globally, it's a different, I mean, I can't answer that. The East has been notorious in under-reporting. But in South Africa, yes, we need stricter reporting rules, and it's more so the small-scale stuff. The big companies have a vested interest to maintain that fishery for the next 100 years.
Yes, yeah. I heard that fish are in danger through the little pearls in the toothpaste. They would eat it and would have no nutrients.
I've never heard of that, I'm sorry. The little pearls in the toothpaste?
Yeah. They would go in the sea, in the waters.
Okay.
And fish would eat it and had the feeling they are
full.
At something.
Yeah.
Have no nutrients.
Yeah, more than likely.
There's a question at the back.
I find it interesting that there's this paradox that you've got a sustainable resource like fish, yet your graph showed quite clearly it was declining and steadily declining. Yet we have non-renewable resources like oil where they're expanding and expanding and expanding. How do you explain the paradox that a renewable resource like fish is declining and the non-renewable resource is expanding?
First, you're assuming that a fishery is renewable if it's at any rate. It's not. A fishery is renewable if it's managed correctly. And that's a very, you must remember that point. And a lot of fisheries have become non-renewable. And obviously, I can't answer that question, but it's where the government or a lot of government mandates are going. And it all comes down to economies. Oil is a far more productive industry than fishing normally, probably provides more taxes. I can't answer why or where they're putting money into.
Okay, one more question. Here we go.
What impact has plastic made on filter feeders?
On filter feeders? That's a good question. None that I know of. All the plastic, or the majority of the plastic pollution that I know of, or that I think is the main, is too large to have an impact on filter feeder.
They export these tiny little pieces of plastic plastic bags and so on. They go overboard on ships
Okay.
and get ingested by these filter feeders.
Filter feeders, yeah. So more than likely have a devastating effect on them if that happens.
Yes.
Sorry, I don't know much about that.
One person trying to get your attention. Let's have one very last question.
I read an article a couple of months ago. You know, there's a toothpaste now with microbial.
I obviously missed this article. I must go find it.
Sorry, somebody else.
Yeah.
Thank you, everyone.
Thank you.
Very much,
No,
Denham.
thank you.